ones before. So we're going to go over a basic solving where it's not a trinomial, and then a solving where it's a trinomial, and then today's stuff, which is the easy part. You're literally just going to swap out something and factor a trinomial. But if you can't factor a trinomial or a binomial, today's lesson is impossible because you have to be able to do that to answer it. Okay? So we're going to look at the stuff we've done before. We're going to look at 3D. So it says solve each equation algebraically over the domain 0 is less than or equal to x is less than 2 pi. Use technology to verify. So to verify this, we would go y1, don't do this, just showing you, reminding you, y2, and then you'd find out where they intersect, take the x values, and give your answers. So if it was a multiple choice, would you have to do this the long way? No, you can absolutely just use your calculator. Okay? Chance of it just being that way, probably slim to none. Okay? So we have cos squared x plus 2 cos x equals 0. What I told you to do before was change that to an m. Now it scares me a little bit because I also reminded you you're probably not going to remember to change it back to a cos, and a lot of you didn't on your test. Okay? So you'd have m squared plus 2m equals 0. So what burns you guys is not trig. What burns you guys is not grade 12 math. What burns you is your quadratics from grade 11 or your decomp from grade 10. So we don't want the grade 10 and 11 math to be the reason why we can't get these questions. Okay? So we have a quadratic. We have something with a squared. The moment we have something with a squared and we want to solve it, we have to get everything to one side, set it equal to 0. This one already is. This one has 2 terms. When it has 2 terms, can we factor it? No. We might be able to if it was like a difference of squares. If it was like m squared minus 4 or m squared minus 9 or something like that, right? But it's not. It's m squared plus 2m. So when it has 2 terms and it's a squared, there's only 2 things we can do. We can take out a greatest common factor or a difference of squares. This is not a difference of squares, so the only thing we can do is take out a greatest common factor. People do worse on these than decomp because they just are stuck. They're like, I don't even know what to do next. Just take out an m. And you're left with m plus 2. In quadratics in grade 11, you learned, hey, I take both of these factors then and set them equal to 0. M equals 0. I'm done that one. And then m plus 2 equals 0. So m equals negative 2. I'm done that one. And then you guys moved on in grade 11. You cannot move on in grade 12. There's actually no m in that question. Not one m. Like you're saying m equals this, but it can't be a solution because the solution is actually going to be x equals, right? Because the variable in that is x. If the variable was theta, you'd go theta equals. If the variable is x, it's x equals. The variable is t, it's t equals. You're telling me m equals, and the person marking this would be like m. M, where's m? Like I don't even know. So remember that if you have an m, there's no m in here. I've solved nothing. I have to replace the m's back with cos. So I have cos x equals 0. And cos x equals negative 2. 0, root 3 over 2, a half, root 2 over 2, negative 1, 1. Those you can pull off the unit circle, right? We agree? So if you get any of those types of answers, you're going to go to the unit circle, and you're going to look to where x is those values. If it's any other value, like a decimal or something wonky that's not on there, you have to do the 3 steps. Reference angle of the positive. So you have to go like cos neg 1 of positive 0.7. Cast rule, get my answers, check coterminals, right? Here, we could just go off our unit circle because it's cos theta equals 0. Where's cos 0? Where's x 0? The y-axis, so here and here. They told me the domain is radians, so can my answer be degrees? No. So, I'm going to have x equals what? Pi over 2 and 3 pi over 2. Do I have to check my coterminals in this case? No, because this question was the nicest question ever. It literally asked off of the unit circle. Boom, done. If you get that, you should do like a little happy dance. Like they're not even asking you for anything outside of the unit circle, right? Cos x equals negative 2. People sit for life. They cannot figure it out. They will freak out. Their calculator, if you go second cos of 2, it errors you. It says it doesn't happen. It's not happening. But why is that? Well, just like up here, y1, y2, you could do this one, y1, y2, right? Cos x is the graph that starts at 0, 1, and it does this. We agree? And then it's asking you for the x-intercepts, technically, which are at pi over 2 and 3 pi over 2. So you could check this in your calculator, could you not? Same thing here. This is y1, this is y2. If I say algebraically and you're y1, y2ing for life, are you going to get any marks? No. So written response, you can't. So if I drew this one out, my cos graph goes like this. We agree? So that's cos x. So this would be y1, arrows. y2 is at y equals -2. What is my graph minimum at? Basic cos. This is -1, right? So here's -2. What are my answers between 0 and 2 pi of where they intersect? None. I don't actually get any solutions from there. So if I have cos x or sin x equaling to anything greater than 1 or less than -1, you should actually rejoice because you can't get any answers from it. You're actually done. These are my answers. That's it. That one gets me no solution. So people freak out, but actually that's like the best thing ever because you can't do it. Moving on, right? So if I give you a quadratic, so degree 2, x squared, or cos squared, or sine squared, or tan squared, or whatever, you still have to move everything to one side and check for a difference of squares or GCF if it's 2 terms. If it's 3 terms, we're going to factor. So this is where it gets harder. So let's go to these ones for now. Actually, I'm going to skip 4. I'm going to go to 5 for now. Sorry. Okay. This one wants me to solve algebraically. Solve means x equals what? That's what I want as an answer. I want you to do some work, and I want you to tell me x equals something, or theta equals something, or whatever the variable is equals something. That's what solve means. Whenever you see solve in math, that's what it means. Whatever the variable is equal to something is what I want boxed at the end. Yay, I'm done. If you do not have x equals something boxed at the end, you didn't actually do what I asked. Okay? So we have to figure out a way to do that. If we have 2 terms, we can GCF for difference of squares. If we had 3 terms, so on your test before you had something like this, 2 sine squared x minus, let's say 3 sine x plus 1. What did we do? We could do decomp, right? What did you guys do? Nothing. Product sum, some crazy things, move stuff to both sides. It was wonky. But what do? We move everything to one side. We can replace the signs with m, and we do decomp. And we'll get 2 answers just like we did in the previous one, right? We'll get a split. We agree? So that one is what we need to be able to do after we figure out a way to get it into that form. So right now we have a sine squared x, a cos squared x, and equals a half. We have 2 sine squareds minus 3 cos 2x. We have some really wonky things going on. Okay? We have sines and coses mixed. In the end, we need to have one thing. We need to have either sines or coses, right? If we have a mixture, it can be awful. So the one we're going to look at first is we'll look at C. So we have 3 cos 2x plus cos x plus 1 equals 0. Is there a formula on my formula sheet that I could possibly use to get something to change so that it's in like a trinomial format where it's like something squared plus something plus number equals 0, so I can just factor it? If I change cos x, the only thing I can change cos x is into 1 over secant x. Is that going to help us in any way? No. So a 1, we can change that into 1 over 1. It's not helping us, right? So really, the only thing we probably can change is that. Why do cos 2x's suck? Because we have options. I'd rather have no options. Just give me one formula, I fill it in, I'm happy. But we have options when it's cos 2x. So we look at the cos 2x formulas. We have options, but really we don't have options. So our first option is cos squared x minus sine squared x. If we fill in cos squared x minus sine squared x, is that being any more helpful? Now we have like a mixture of both. If we fill in the 1 minus 2 sine squared x, now we have a sine squared x, a cos, and a number. Still not too helpful. So the only one that's probably helpful is the cos squared one, right? Because we need coses. So the 3 stays a 3. The cos 2x gets replaced with the cos 1. So 2 cos squared x minus 1. Plus cos x plus 1 stays the same. Nothing happened to that. So really, we're trying to get this trinomial into some format, hopefully, of like cos squared, cos, number, 0, factor it, right? So now we at least have a cos squared, we have a cos, and we have a number. This looks pretty good. But what are we going to have to do first before we can even do anything? Yeah, distribute that 3 in and then collect like terms. So we're going to get 6 cos squared x minus 3 plus cos x plus 1 equals 0. We're still not in the proper format. We need to be 6 cos squared x plus cos x, combine the negative 3 and the 1, so minus 2 equals 0. That's all we're learning today, that part. The swap and get it together. We're not relearning this part. This part has been learned. You're learning it if you have no idea how to do it. But this part has been taught to us, right? This part is a repeat. So is today really a hard lesson? No. We have to just figure out go to the formula sheet, what could I replace to make this actually work? That's all the lesson is today. This is part of the lesson. We're going to go through it. But is this new? No, that was taught to you before. So this little teeny tiny part up here is the new part. So is this really the hardest part of it? No, the hardest part is doing what we did before and getting an answer. Okay? So we're going to replace m equals cos x. So we get 6m squared plus m minus 2 equals 0. Remember, first step is admittance. If you still can't do decomp, you need to come in and ask for help. Okay? Because I don't know exactly what you do and don't know. Okay? We have to do decomp. Why do we have to do decomp? Why can't we just go straight to brackets? Because there's a 6 in front of the m squared. So we're going to go what times what equals the first times the last. 6 times negative 2 is negative 12. What plus what equals the middle, which is 1. What's it going to be? 4 negative 3. Now, so many of you went x plus 4, x minus 3, and solved it out. Not helpful. Okay, first off, that would be cos equal to 4 and cos x equals negative 3. You have no solution. Both of those are above and below 1 and negative 1. So you'd be like, yay, she said this was the best. Probably not true. Also, remember, you can check these. You could go y1, y2 and see how often they intersect, right? So if they do intersect, you know you messed up because you would say there's no solution here. So decomp, we keep our first term. We replace our middle term with positive 4m minus 3m because that is 1m. We're just replacing, right? Minus 2 equals 0. Group. I'll sign in between. I can take a 2 and an m out. I'm left with 3m plus 2. Take out a negative 1 and I'm left with 3m plus 2. So I get 2m minus 1 and 3m plus 2 equals 0. Very different than m plus 4m minus 3. We agree? Okay, pay attention. We have to be able to do this. So we need to solve them out separately. 2m minus 1 equals 0. 3, everyone should be writing down. 3m plus 2 equals 0. 2m equals 1. Divide by 2. M equals a half. 3m equals negative 2. Divide by 3. M equals negative 2/3. So if we're looking at this question, the red is the new. The black is everything we know. Majority of this question is what we should know, right? Not new. Okay, m equals, yay, we have answers to m, except I need answers to x. Yeah. So cos x equals a half. I'm very excited when I see this because I know that's an answer on my unit circle. Cos x equals negative 2/3 is more work because That is not on my unit circle. So cos x equals a half. Where is x a positive a half? Well, x is positive here and here because that's where x's are positive in the quadrant. And it's at 60s. Because I just go look for where x is positive a half. And that's at pi over 3 and 5 pi over 3. So those ones aren't bad because they're on my unit circle. X equals pi over 3 and 5 pi over 3. We agree? The other part, we need to do reference angle first. Cast rule answers. Okay? Reference theta. Some people are still taking the negative. I would suggest that you don't. So reference x equals cos neg 1 of 2/3. The reason why we take the positive is because if we take the positive, it gives us a reference angle in the first quadrant. If you take the negative, it could be anywhere. Okay? Especially not the first quadrant. So I'm going to make it in radian. So second cos 2 divided by 3. So it's 0.84106866706. Do I have to put rads behind it or radians? No, because if there's nothing, we assume it to be yay. The only time you have to put something for sure is if it's a degree, you have to say it's degrees so we know it's a degree. If you don't put the degree symbol, we assume it to be a radian. Okay, step 1, reference angle. Step 2, cast rule. Cast rule is based on your angle. And by your angle, I mean your sine. I don't know why I just said angle. It's based on your sine. Your sine is negative. So we have to put the arms where cast or where cos is negative, which is here and here. Because it's it's A-C-S. Oh my gosh, C-A-S-T. I was trying to do it from A, but it was not working with my brain. C-A-S-T. Okay? So it's where cos is not positive. And why? Because we look at the actual question. Our reference angle is always going to be positive, but the question may not have been positive. Now, what's in here for radians? Pi. So to get this one, I'm going to go pi minus this. To get this one, I'm going to go pi plus this. And I know some of you are degree masters, like you just really want to stay in degrees. This question is not easier in degrees, as much as you may think so. You'll get it in degrees. It's a crazy wonky decimal. Then you have to convert that crazy wonky decimal to radians. And you have to keep all the decimals along the way because if you round, it could be bad. Okay, so I'm going to go pi minus my answer. And I'm going to get x equals 2.3. And then I'm going to do pi plus my answer, plus my reference. And I get 3.98 or 4.0 technically. So what are my answers to this one? X equals pi over 3, 5 pi over 3, 2.3, 4.0. Now some people will say, how can I make 2.3 and 4.0 exact values? You can't. They can't ask it as exact values. Why? Exact values often screams on the unit circle. Is that on the unit circle? No. Okay. So what's the hardest part of the lesson today? Doing the previous math, right? So if you have a basic cos is degree 1, and you have something else that's not degree 1, you can really only switch the stuff that's not degree 1, technically, right? For the most part. So what formulas are we probably going to be using in here? The Pythagorean theorem identity formulas, because you can get a cos to become a sine, right? So if I had a cos squared but I needed a sine squared, I would just replace cos squared with 1 minus sine squared. But when I replace, I need to replace in brackets, because if there's a number in front or a sign in front, it goes in. Okay, you have to remember that. Or there's these ones. These are the other ones that get replaced a lot. Sine 2 theta, cos 2 theta. So that's what you're going to be replacing with most often. Okay? You don't have a lot of questions in your homework on it. So I'll just give you a few. But you have to finish your proofs as well, and we'll go through the proof answers. I'll show you them at the beginning of class tomorrow. The rest of them, yeah. So I think there's like 5 more left or something. Because I did the 1, 6 more left. So this is the last lesson of trig that we just went over. Logs and exponentials is next. So, page 320. numbers 2 and 3. And for past practice, do number 4. Now put a hint beside number 4 that when you solve for number 4, it's 4 sine squared equals 1. When you solve for number 4, remember, you're going to move the 4 over. It's 4 sine squared x equals 1. You're going to divide by 4, and then you're going to take the square root to get sine by itself. And when you take the square root, what do you have to do? Plus or minus. So you're going to get 4 answers. You're going to get the positive quadrants and the negative quadrants. You have to remember that when you have a difference of squares one. Okay? Yeah, work through those. Yep. Yeah. And if you want extra practice, there's always the chapter review on page 322. It reviews everything. Everything.